Uh, Hello all. So in this video we are going to see an example of double and add algorithm for elliptic curves for adding a point p on an elliptic curve n times. So p plus p n times using double and add algorithm for two values of n equals to 9 and n equals to 10. And so our elliptic curve is y square equals to x cube plus ax plus b. So for us a equals to 2, right? B equals to 3, and the point P is we have taken is 7 comma 3 in elliptic curve over E over F13. So our prime is 13, and this is a point one can check by plugging the values, sorry, y and x, that this point is on the elliptic curve. Okay, so what is the method we are going to follow is given in the book Introduction to Mathematical Cryptography by Hofstein, Pfeffer, and Silverman. So this is a table. Uh, Computations is the next step, but first this is how the table we make. So step number I, then n, then the value of q equals to 2 raised to I times p, and then our result is r. So this table I am making for n equals to 9. So this is table for 9, and then another table I'm making at the same time, so we can compare n equals to 10, q equals to 2 raised to I times p and r. Okay, so sorry, so this is the table for n equals to 9, and we'll do this calculation simultaneously so that we understand. Okay, so first step is this, the first row is common. Step number 0, value of n, here it is 9. In this example, same example, but we are doing two computation, 9p and 10p. So here it is 10. And for step number 0, I equals to 0, 2 raised to ip is nothing but 2 raised to 0p, which is p. So this is nothing but p, 7 comma 3. Here also p. This is common. First row is common for every example. So here is the value of p, and first our result r, resultant point r is the point at infinity, point O. So this is common, this row is common for every example. Okay, now our computation starts. So first step, step numbers, not first step, zeroth step, step number 0, just write the value of n. Okay, and so n is 9, here the point p, here also point p, 7 3, same, O and r equals to O. Okay, now step number 1, so 9p, so 9p means 9 we have to write in binary. So binary we write like this, 2 cube, then 2 square, 2 raised to 1, and 2 raised to 0. So 8 4 2 1. And how do we write 9? How do we write 9 is 1 0 0 1. So 8 plus 1 9. So 9p equals to 8p plus p. That means 2 raised to 3p plus 2 raised to 0p. Okay, similarly here also we have to write 10. Just comparing, not writing, but just we can see 10p. 10 means 8 plus 2. So 10p is nothing but 2 raised to 3p plus 2 raised to 1p. That means 8p plus 2p. Okay, so this is how our computation will follow. You can see here. So for step number 1, n we divide this by 2. So 9 by 2 is 4.5. So we write 4 as a quotient. 4 into 2 8. Okay, plus remainder 1. Okay, now remainder we are not writing this. In many other books this notation is used. The bit is used extra, 0 or 1, whatever the remainder is, but in our book it is not used. But this is what we do. If the remainder is 1, then we add these 2 points here. Okay, if the remainder is 0, then we don't add, we just copy the previous one. So what will happen here? You can see the remainder is the remainder is because the remainder is 1, we add p plus o. So p plus o is nothing but p, right? This is p plus o equals to p. What happens here? So this is first step here. What happens? We divide 10 by 2. So we have 5 as a quotient. Remainder is 0. Since the remainder is 0, we don't add. We just copy r. So r is o. Whatever r value is, we just copy. We just carry it forward. Continue. Okay, so this is the first step, right? First row is common in every example. 0, 0th step. Write the value of n. 2 raised to 0 p, that means p, and r is o. First row is common. Then in the first step, divide n by 2. Write the quotient. Okay, wait here. If the remainder is 1, right? Remainder is 1, add these 2 points here. Remainder is 0, don't do anything. Just copy this one here. No need of addition. So here, here you can observe that we have got p because p is there. Here p is not required. 8p plus 10p is just 8p plus 2p. So here o is there. Okay. Now the quotient is non-zero. Then we double the point. Okay. Quotient is 4 here. So we double the point 2p. We compute 2p. Quotient is here 2p. We compute this. Okay, so let us compute 2p. We know how to we compute using the formula, but I recommend before using the formula, always keep inverses handy because that will be useful. So 1 inverse is 1 modulo 13. 12 is minus 1, so 12 inverse is minus 1 inverse, which is minus 1. All computations are modulo 13. 2 inverse. So we know 2 into 7. 2 into 7 is 14. 14 is 1 modulo 13. So that means inverse of 2 is 7. Same time inverse of 7 is 2. 3 inverse. So what is 3 into something? Uh, we want 1 modulo 13. 1 modulo 13 means either it can be 14, 13 plus 1, but there is no 14 in the multiple of 3. So it can be 13 into 2 plus 1, 27. Yes, this is there. So 3 into 9 is 27. So 3 inverse is 9, 9 inverse is 3. 4 inverse. Again, 4 into what gives us 1 more 13? 1 more 13 means 14. 14 is not multiple of 4. 27 is not there. So 13 into 3, 39 plus 1, 40. Yes. That 4 into 10 is 40. So 10 is the inverse of 4. Inverse of 10 is 4. And inverse of 4 is 10. Okay, then 5 inverse. Again, 5, 14 is not a multiple of 5. 27 is not a multiple of 5, but yes, 40 is a multiple of 5. 5 into 8 is 40. So 40 is also 1 modulo 13, 39 plus 1. So inverse of 5 is 8. Inverse of 8 is 5. Okay, now 6 inverse. 6 inverse, we can also compute like 6 into something is not 14. 6 into something is not 27. 6 into uh, something is not even 40. Then what is next? 13 into 4. So 52 plus 153. So that is also not there. Then what is there? 13 into 5. 65 plus 166. Yes. 66. So 6 into 11. So inverse of 6 is 11. And inverse of 11 is 6. Anyway, I did this. Otherwise, one can check also for last one. 1, 2, 3, 4, 5. Then 7 has come, 8 has come, 9, 10, 11, 12. So 6 and 11, only 2 are remaining. So we don't need to even go for 66. We don't need to even look for 66. We can directly just say that 6 inverse is 11. But no, we have to check. 6 inverse should not be 6 first. Then it should be 11. And 11 inverse is 6. Okay, so now let us compute 2p. So 2p is p plus p, which is 7, 3 plus 7, 3. We know that formula for computing 2p. What is the slope? Lambda equals to 3x1 square plus a upon 2y1. Okay, so 3 and x1 square, 7 square, plus a is 2, y square equal to x cube plus 2x plus 3. You can see a equals 2, right? Okay, so coming back to this, and so a is 2, 2y1, y1 is 3. Okay, so now 7 into 7, 7 square 49, 13 into 3 39, so that is 10 remaining, so plus 2 upon 6, so 32 by 6, so 32 by 6, that will be 16 by 3, but 16 is again modulo 13, it is 3, 3 by 3, so this is 1 modulo 13. Okay, so lambda is 1, x3 is nothing but lambda square minus x1 minus x2, but here x1 and x2 both are same, so I'm just going to write because 2p, right? So x1 minus x1, so this is 1 square minus 7 minus 7, so minus 7 minus 1 minus 14 and plus 1, so minus 13, which is nothing but 0 more 13. Okay, and y3 is lambda x1 minus x3 minus y1. So this is 1 times x1, that is 7 minus x3, 0 minus y1. So this is uh, x1 is 7, yes, lambda is 1. Okay, so 7 minus 3, 4. Okay, so our point is 0 comma 4. So this is 2p is 0 comma 4. It will be helpful here also 0 comma 4. Okay, because see, again repeating what we did quickly. First row is common, step number 0, write step 0, value of n 2 raised to 0 p. This is always p in every example, whatever p is there, and this is always 0. Now first step, divide this by 2, write the quotient, remainder is 1, then add this 2, above 2 comes here, so p plus o comes p, so we have p. Remainder is not 1, remainder is 0, so no need to add, just take this forward, so o is carried forward. Okay, and because now quotient is non-zero, we don't stop, we calculate 2p. Is it clear? I hope it is clear. Just let us go to next step, step number 2, divide by 2, divide by 2, so 2 into 2 4, remainder is 0, remainder is 0, just carry forward, so p here it was p, we just write p here. Okay, what happens to 10p? Divide by 2, 2 into 2 4, remainder is 1, remainder is 1, so we need to add this 2 and bring this in this next step, so 2p, 2p plus o, this is 2p. Is it fine? So see here, p is always coming, it is p, because in 9p we need p, and then when 8p will come, then we'll add this 2, but in 10p we don't have p, so we are having o, and then 2p, so 2p has come because the remainder is 1 here, so 2p has come, and then 8p will come. Okay, just going, so now the quotient is non-zero, quotient here is 2 both, so we do 2p plus 2p, so we compute 4p. Okay, so let us compute 4p. So inverses will help. So 4p, which is nothing but 2p plus 2p, which is 0 4 plus 0 4. So lambda equals to 3x1 square plus a upon 2y1, which is 3 into 0 square plus 2 upon 2 times y1. So this is 2 upon 8. So this is 1 by 4. And what is the inverse of 4? 1 by 4. So inverse of 4. That's why these inverses are helpful. So it's 10. So easily we can write. Now this is 10 modulo 13. And x3 is lambda square minus x1, which is 10 square minus 0 minus 0. x1, right? 0, 0. So 10 square, 10 is nothing but I can subtract 13 from 10. So 10 is nothing but minus 3. Minus 3 square, which is 9. And y3 is lambda x1 minus x3 minus y1. So lambda is 10, x1 is 0 minus x3. x3 is 9 and minus y1. y1 is 4. So minus 90 and minus 4. Or I can write as 10 as minus 3 into minus 9 minus 4. So this is 27 minus 4. So 27 and then modulo 13. So this is 23. 23 modulo 13, which is nothing but 10. So our point 4p we have computed. This is 9 comma 10. So this is 9 comma 10. Okay, now next step number 3, divide by 2. Okay, so quotient is 1, remainder is 0. Remainder is 0, nothing to do, just write p. Again, step number 3, divide by 2. 2 into 1 is 2, remainder is 0, so write 2p. No need to do anything. Okay, and now we need to compute 8p because still the quotient is 1. Okay, and when n becomes 0, then only we stop. So now we need to compute 8p. So let us compute 8p. So 8p is 4p plus 4p, 9, 10, 9 comma 10 plus 9 comma 10. Let us do that. Okay, 8p equals to 4p plus 4p, which is 9 comma 10 plus 9 comma 10. And so lambda is 3x1 square plus a upon 2y1, which is 9 square, but 9 minus 13, so it's minus 4 square I can write. You can also use 9 square, not a problem. Answer will be same if you don't make mistake, upon 2 times. So this is 4 into minus 4 into minus 4, 16. 16 is nothing but 3 modulo 13, so this is 3 plus 2 upon 20. 3 into 3, 9. 9 plus 2. 9 plus 2, 11. 11 upon 20. I can write 11 as minus 2 also. And 20, or I can write 20 as 3 modulo 13. Sorry, 7 modulo 13. Okay, so this is 7 inverse. 11 I can write minus 2. And what is 7 inverse? So 7 inverse, yeah, 7 inverse is 2. 1 upon 7, so that's 2. So this is, or I can just use 11 only. 11 into 2 is 22. 22, so that is 9 modulo 13. So lambda is 9. And what is x3? Lambda square minus x1 minus x1. 9 square minus 9 minus 9, which is 9 I take common. So 9 minus 1 minus 1. So 9 into 7. 63. 63 and 13 times 4 is 52. 52 and 63, so this is 11 more 13. y3 is lambda x1 minus x3 minus y1. So this is lambda is 9, x1 is 9 minus x3 is 11 minus y1 is 10. So 9 into minus 2 minus 10. So this is minus 18 minus 10 minus 28 minus 28. So add 26. So we have minus 2 and again add 13. So we have 11. Multiples of 13, same answer. So this is 11 comma 11, x3 comma y3. So 8p we have computed, 11 comma 11 11 comma 11. Okay, and now finally fourth step. Fourth step. So divide by 2. So 1 by 2. Quotient is 0. Okay, quotient is 0. Divide by 2. Quotient is 0, but remainder is 1. When remainder is 1, we have to add. So that you can see here we are getting 9p. So now we have to add this 2 because 1 by 2. Okay, quotient 0 times 2 plus 1. Remainder is 1. So now these two are added. Okay, so here we will have 8p plus p, which is 9p, and 9p we will compute. So 11 comma 11 plus p, which is 7 comma 3. This is what we'll do here. What happens? Same thing here. Okay, divide by 2. 1 is divided by 2. Quotient is 0 times 2 plus 1. So remainder is 1. So these two are added. 8p plus 2p. Okay, so here we have 10p, 8p plus 2p. Here it is added. And since the quotient is 0, now 16p we don't need to compute. Okay, since the quotient is 0, 16p we don't need to compute. So just final calculation remaining here. 8p plus p and 10p, so 8p plus 2p. 2p is 0, 4. 2p is 0, 4. Okay, so first let us compute 8p plus p and then 8p plus 2p. Okay, so last step, 8p plus p, which is 11 comma 11 plus 7 comma 3. And so here now lambda is y2 minus y1 upon x2 minus x1, and this is 3 minus 11 upon 7 minus 11. So this is minus 8 and this is minus 4. So this is 2, and x3 is lambda square minus x1 minus x2. So 4, 2 square is 4 minus x1 11 minus x2 minus 7. So minus 7 and minus 7. 4 minus 11 minus 18. Minus 18 is minus 5. So 4 minus 5 minus 1. So this is will be 12. Okay, if you don't understand all this, just do it on your own. The calculation, okay? I'm getting 12. And y3 is lambda x1 minus x3 minus y1. So I got here actually 4 minus 18. So minus 14. Minus 14, I added 13, so I got minus 1. Minus 1 again, I added 13, I got 12. That's how I get. Okay, I hope this is correct. I don't know. I will have to check if I have not made a mistake. And so this is lambda is 2, x1 is 11, minus x3 is 12, and minus y1 is 11. So this is minus 2 and minus 11. So minus 13, which is 0 more 13. Right, this is minus 1 and 2, so minus 2 and minus 11. Okay, so we have got point 12 comma 0 here. That's it, done. We are done for first example. 12 comma 0, this should be the answer. Let us check. And then here in the other one we have to compute this 2p plus, so I'm not, we should write here actually, instead of 2p we should write 0, 4, 0 comma 4. So 0 comma 4 and 11 comma 11, so two things to be added. Okay, so 8p plus 2p, which is 11 comma 11 and 0 comma 4. So lambda is again y2 minus y1 upon x2 minus x1, which is 4 minus 11 upon 0 minus 11. So minus 7 upon minus 11. Yeah, and so 7 upon 7 upon 11. What is the inverse of 11? Inverse of 11 is 6. So this should be 7 into 6, 42. 42 and 13 into 3, 39. So remaining 3. So 3 mod 13. and x3 lambda square minus x1 minus x2. So this is 3 square minus 11 minus 0. So 9 minus 11, which is minus 2, which is again 11 mod 13. Yeah, and y3, this is lambda x1 minus x3 minus y1. And so this is 3 times x1 is 11 minus x3 is what we got 11 now. And minus y1 is also 11. So this is minus 11, which is nothing but 2 mod 13. So this is 11 comma 2, x3 comma y3, 11 comma 2. Let us check. Okay, so this is 11 comma 2. I hope this example is clear now, but let us go to our website and check these values. My website, and then you go into semester courses, look for fourth semester or third semester double linear algorithm, and let us compute. So prime fp f13, so prime is 13, value of a y square equal to x cube plus 2x plus 3. So this is 2, b is 3, coordinates of point 7 comma 3. So x coordinate is 7, y coordinate is 3, and n is 9. So you can see you get the entire solution here. P carried forward, and here 8, and this is 12 comma 0. Yeah, we got 12 comma 0. So 9p, that's our correct answer. So that's 12 comma 0. And let us now check about 10p. So prime is 13, a is 2, b is 3, coordinates is 7 comma 3, and n is 10. So 10p is 11 comma 2. Here you can see the table, whatever we have computed, 11 comma 2. Yes, so we have computed, that's correct. Okay, so finally let me do one more table, just not computation, only table. So you can also do it on your own. N equals to, take something 11, take n equals to 14. Okay, so step I, n, and then q equals to 2 raised to ip, and then r. Okay, so step number 0, n is 11, this is p, whatever the coordinate is, 7 comma 3, and r is o. Okay, divide by 2, 5, remainder is 1, so we add this, so p plus o, these two are added now, p plus o. Okay, again compute 2p, whatever it is. Next step, divide by 2, so 2, remainder is 1, then this 2 should be added, so we have to add these 2 points, 2p and p, that calculation we have to do, so this becomes 3p. Compute sorry, compute 4p then. Okay, then in the third step, divide by 2, quotient is 1, remainder is 0, don't do anything, just write 3p here, compute 8p. Finally, fourth step, quotient is 0, remainder is 1, then add this 2, so 8p plus 3p we add whatever the point is, and we get 11p. And 16p we don't need to compute actually, so this we don't need, we leave it blank. Okay, so similarly n equals to 14, same thing. Just let me finish this by writing this table. So q equals to 2 raised to ip and r. Okay, first row is always common. Step number 0, n value is 14, 2 raised to 0 p is always p, whatever the point is, 7 3 here in this case, this is always o, this is always there. Now step number 1, divide by 2, so 7, remainder is 0, just write o, no need to add these 2 points in the previous row. Step number 2, divide by 2, so now compute 2p, so whatever 2p, I think we got 0 4, whatever the value is. Now divide by 2, so 2 into 3 is 6, remainder is 1, then we add these two previous entries, so we get 2p. 2p plus o, that is 2p, and we compute 4p. Step number 3, divide by 2. Quotient is 1, 1 into 2 is 2, and plus 1, plus 1, remainder is 1, so we add this 2. Okay, so 4p plus 2p, we have 6p. Okay, compute 8p. Then step number 4, quotient is 0, remainder is 1. The remainder is 1, so whatever 8p point we have got, 11 comma 11, and 6p, we add these 2 points, 8p plus 6p, whatever the point is, whatever the answer is, and 16p we don't need. Okay, because now the quotient is 0. So I hope this is clear. For your practice, you can compute 11 p and 14p.